Okay, so we have been working with solving linear equations. We're going to make them a little more complex in this set of examples by including fraction terms in the equations. There's more than one way to work through these problems, so I'm going to try to show you a variety and let you determine what is best in each situation. The first example is 2x over 3 minus 5 equals 7. Since I have only one fraction in the entire equation, to me it makes most sense to just deal with it as it is. So that normally means we're going to isolate my x term and get it by itself so the numbers are all on the other side. That means we have to get rid of this minus 5, and we can do that by adding to both sides. Great. All right, so now we have 2x over 3 equals 12. Now, 2/3 or 2x over 3 is really the same as 2/3 x. Well, 2/3 x means I am multiplying, so that means to undo it, I need to divide both sides by 2/3. Some of you may remember that if you divide by a fraction, you're really multiplying by its reciprocal. So you could work out just on paper 12 times the reciprocal of 2/3, which is 3 over 2. If you're not good with fractions, you're unsure, it's been a while, no problem. Just get your calculator. What we're going to have to be careful of, though, is order of operations. We need the calculator to understand that it needs to divide by that 2/3. So it has to do that first, and we accomplish that by putting that in parentheses. That tells the calculator do that first. All right, so let me get my calculator out here, and I'm going to clear everything, and I'm going to say 12 divided by, and I'm going to put parentheses, and 2/3. How do you put that in your calculator? Well, a fraction is just top divided by bottom, so 2 divided by 3, and close that parenthesis. So now I see 12 divided by the 2 divided by 3, so it's going to do that first inside the parenthesis, then it's going to do the 12 divided by the answer. So I hit equals, final answer is 18. So on the left-hand side, 2/3 divided by 2/3, of course, is 1x. And on the right-hand side, we got 18. Now we've talked about checking in other videos. I'm going to let you check this one. My next example has all the terms that are fractions. So I probably want a little bit different method. One method is to make all of the fractions have the same denominator. Usually we go for the lowest number, LCD, lowest common denominator. That means the smallest number that all of my original denominators will divide into. So my problem here, z over 5 minus 1/2 equals z over 6. My denominators are 5, 2, and 6. Obviously, everything doesn't divide into 6, so I have to get something bigger. Let's try 5 times 6. What about 30? Well, obviously 5 and 6 both divide, and 2 divides into 30, so I think we can use LCD of 30. So what I'm going to do is take all the original fractions and make them something over 30. So I'm just going to rewrite my problem here with denominators of 30. My first term is z over 5. In order for that 5 to become a 30, I'd have to multiply it by 6. In order to keep my fraction equivalent, I also need to make or multiply the top by 6. So we end up with 6z over 30 is equivalent to z over 5. Doing the same thing for each of the others, I look at the second fraction here, it's a 1/2. So multiply the 2 on the bottom by 15 and I'd have 30. Do the same to the top, so that becomes 15. 1 times 15. The last one, z over 6, we'd have to multiply the bottom by 5, so we'll multiply the top by 5 and get 5z. Here's the fun part. Now that I have all the denominators the same, I get to ignore them. And I just look at the equation basically with the numerators, the top part, which would be 6z minus 15 equals 5z. Normally I like to keep my variable terms positive, but I'm going to break that rule in this particular problem because it saves me a step. So I have 6z minus 15 equals 5z. Let's get all the leave the number term where it is and move all the variable terms to the right-hand side by subtracting 6z from both sides. That leaves me with, watch those signs, negative 15 equals negative 1z. 5 minus 6 puts you 1 in the hole. Now I want plain z, so I have to divide through by negative 1. And I'm going to get my final answer then of positive 15 equals z. Once again, I'm going to let you do the check. Last one. So in this one, I have y over 12 plus 1 over 6 equals y over 2 minus 1 over 4. Rather than change each fraction to have the common denominator and then ignore it, we're actually going to multiply each of the terms by the common denominator. Okay, so once again, I'm going to start with the biggest one, which is 12. Look at all the others and see if they divide into it. 6 divides into 12, 2 divides into 12, and 4 divides into 12. So for this one, we can actually use a common denominator of 12. So rather than change my fractions again to have that denominator, I could multiply each one by that. So the first fraction, I'm going to multiply by 12. But since I'm multiplying a fraction by something, I'm going to multiply by something that also is a fraction form. 12 is the same as 12 over 1. Now it looks like I'm multiplying a fraction by a fraction, which reminds me that I multiply tops and I multiply bottoms. I just think it's an easier form. You don't have to do this, but I think it looks nicer, helps most of us if we're going to do it that way. Right? So what we do to keep the balance, multiply every single term in the original problem by that common denominator. Even if one of them had not been a fraction from the outset, we'd still have to multiply it by the common denominator. So let's see what we get. Multiplying tops and bottoms, we get 12y over 12 plus 12 over 6 equals 12y over 2. Minus 12 over 4. Now I need to reduce these. So the first one, 12 divided by 12, leaves me 1y, plus 12 divided by 6 is 2, equals 12 divided by 2 is 6y, and lastly, minus 3, 12 divided by 4. Now I've got one variable, one number on each side. We can simplify as normal, which means variables to one side, numbers to the other. So here I'm going to go ahead and subtract y from both sides, leaving the y's on the right-hand side. Then I need to remove the minus 3 on the right by adding 3 to both sides. Now adding vertically or combining vertically, we're going to get 5 equals 5y. And last, we want to get y by itself, so I need to divide. And my final answer here then is going to be 1 equals y. Once again, I'm going to leave it to you to go ahead and check this and let me know if you have any questions.